Hello friends, welcome to Engineering Tiger. In today's session, we are going to solve numerical based on the law of machine. Before starting this video, I just remember you that you just subscribe our channel and press bell icon to get the next video's notification. I hope that you all are taking care of yours and your loved ones in this pandemic situation. So let us start for today's session. So here we are taking one numerical based on the law of machine. The example is, for a certain machine, the law of machine is P is equal to 0.09 W plus 6 Newton. Calculate the effort required to lift a load of 6 kilonewton. Also, calculate the maximum MA and identify the type of machine if VR of machine is 20. So first of all, write down the data which is given in the example. So the given data P is equal to 0.09 W plus 6 Newton. Then the load of 6 kilonewton means the W equal to 6 kilonewton, converted into Newton because P is in Newton. So we will convert this W into Newton, so it will become 6000 Newton or 6 into 10 raised to 3 Newton. Then here velocity ratio of machine is 20. So VR is equal to 20, and we have to find the effort required, that is P. Effort required, that is P. Then maximum MA, and we have to identify the type of machine. Identify the type of machine. In previous lecture, we have already discussed about the types of machine and how to identify it. If you have not gone through that video, then the link is given in the description box. Please watch that video for understanding the type of machine and their conditions. Now here the law of machine is given. So by using that, we have to find out this P. So to find the effort P, we'll use the law of machine. P is equal to 0.09 W plus 6 Newton. Now this W is also given. So 0.09 into 6000 plus 6 Newton, and that is equal to, calculate it, 0.09 into 6000 plus 6, that is 546. So 546 Newton. So Our first is effort required to lift a load of 6 kilonewton, that is 546 Newton. So this is our first answer. Now second, maximum MA. So the maximum MA formula is, maximum MA is a reciprocal of the slope of line. So maximum MA is 1 upon m. But in this example we don't have m directly, so we will compare this law of machine with the standard one. So comparing P is equal to 0.09 W plus 6 with P is equal to mW plus C. We'll get m is equal to, now compare. So this m is 0.09, so we'll get m equal to 0.09. Now put this m equal to 0.09 in the formula of maximum MA. Therefore maximum MA equal to 1 upon 0.09, and that is equal to 11.11. So maximum MA is 11.11, no unit. So our second term is maximum MA equal to 11.11. Okay, now our third parameter is to identify the type of machine. So for identifying the type of machine, we require the efficiency of machine. So first of all, we will calculate the efficiency of a machine by using this maximum MA. That means we will calculate the maximum efficiency of machine. So maximum efficiency of machine equal to maximum MA upon VR into 100. So equal to maximum MA is 11.11 upon velocity ratio. Now velocity ratio is given, so it is 20 into 100. So we'll get the 5 and 55.55 55.55%. Now if the efficiency of machine is greater than 50%, then machine is a reversible machine. The condition is what? If the efficiency is greater than 50%, then machine is a reversible machine. Now here it is 55.55. That means it is a greater than 50%. Therefore the machine is a reversible machine. Since efficiency equal to 55.55%, which is greater than 50%, then the given machine is a reversible machine. Reversible machine. So for deciding the type of machine, we required efficiency, and then using the condition we can decide whether it is reversible or irreversible machine. Is it clear? Now let us take second example. In a lifting machine, a machine of 10 kilonewton is raised by the effort of 300 newton. If the efficiency is 75%, calculate MA and VR. If the machine lifts 20 kilonewton load by the effort of 550 newton, find the law of machine. In the previous example, the law of machine was given, but in this example we have to find out the law of machine from the given data. So first of all, write down the given data. A load of 10 kilonewton, that means W equal to 10 kilonewton, convert into Newton, so it becomes 10,000 Newton or 10 into 10 raised to 3 Newton. Now the effort of 300 Newton, that means P is 300 Newton. The machine efficiency is 75%. So efficiency is also given. Efficiency is 75% of a given machine. Calculate MA and VR if the machine lifts 20 kilonewton load by the effort of 550 Newton, and find the law of machine. So in the first sentence, there is a load and effort with efficiency is given, and we have to find out the MA and VR. Okay, and then we will calculate we will find out the law of machine from the given load and the effort. So here first load is suppose W1, first effort is suppose P1, then the second one is W2 is equal to 20 kilonewton, that is 20,000 Newton, and for lifting this 20 kilonewton, the efforts required is what? 550. So that is P2 equal to 550 Newton, and then decide to find out the law of machine. So to find in first case we have to find out MA, second one is VR, and third one is we have to find out the law of machine. So let us start for solution. So first, to find MA we required W and P, because it is a ratio of W and P. So for calculating this MA we required first case. So MA equal to W upon P, so it is 10,000 upon 300. So it is 100 upon 3, that means 33.5 33.33. So MA equal to 33.33, no unit. Okay. Now second, velocity ratio. So to find the velocity ratio, to find VR, now here the efficiency is given, MA we have already calculated, then we can find out the VR from the formula of efficiency. So efficiency equal to MA upon VR into 100, VR into 100. So by putting the values of efficiency and MA, we will get the VR. So let us put efficiency is 75 is equal to MA is 33.33, VR we have to calculate into 100. Therefore velocity ratio equal to 33.33 upon 75 into 100. So by calculating it, we'll get the 33.33 into 100 means 3333 upon 75, and that is 44.44. So VR is 44.44. It is also unitless. So here velocity ratio equal to 44.44. Now find the law of machine if the machine lift 20 kilonewton load by efforts of 550. So for finding the law of machine, we will use also second case. Okay. So to find the law of machine, here the given data is W2 is 20,000 Newton and effort is 550 Newton. So W is 20,000 Newton and P is 550 Newton. W2 P2. So the basic law of machine is what? P is equal to mW plus C. Now P is P is 550 Newton and W is 20,000 Newton, but we don't have m. So we can calculate m. Now from the first load and the effort, we'll get one law of machine. Then by using this W2 and P2, we'll get the second equation. So let us put the equation one by one. So for the first case, P is 300 is equal to m is unknown, W is 10,000 plus C. Secondly, 550 is equal to m is unknown into 20,000 plus C. So this is our first equation, this is our second equation. Now we have to cancel this C, so we require minus sign, so subtract second from the 1, so we'll get, so change the sign of each term, so it is also minus, we'll get 300 minus 550, so that is minus 250 is equal to 10,000 yum minus 20,000 yum, that means minus 10,000 yum, and C minus C will be cancelled, so we'll get yum is equal to minus 250 upon minus 10,000, so it is 1 2 3 suppose, that is 0.025. You can use calculator also. So here we'll get yum is equal to 0.025. Now by using this yum, we can write down the law of machine in general for this machine. Therefore, law of machine is equal to P is equal to yum is 0.025 W plus C. Okay, now from this equation or from this law of machine, if the P is given, we can calculate W. If W is given, we can calculate P. So here we have already find out the law of machine. P is equal to 0.025 W plus C. Now this is the law of machine for this particular given machine. In this way we can calculate easily the given calculate the law of machine from the given data. Here I forgot this C value, so when we get this yum, we can put this yum in equation number 1 or 2 and then calculate C. That value C we have to put in the law of machine, and then final law of machine of this particular lifting machine will get. So let us calculate C by putting the yum in the equation number 1. Put yum is equal to 0.025 in equation 1. So equation 1 becomes 300 is equal to, now yum is 0.025 into 10,000 plus C, so it is 300 is equal to it is 250 plus C. Therefore C is equal to 300 minus 250, that is 50. Now we can finally write down the law of machine, and that is P is equal to 0.025 W plus C. So this is our final answer for this lifting machine. Whenever we have to find out the law of machine, we require this yum value and C value. Then if P is given, we can easily calculate W. If the W is given, we can easily calculate the P. Here I am giving two examples for practicing. Try to solve these two examples. In the first example, we have to find out the efforts required to lift a load of 3 kN, and in the second example, we have to find out the law of machine, similarly which we have solved in the second example. That means we have to find out the M and C by using these two loads and two efforts, and then maximum efficiency. For that we required maximum MA equal to 1 upon M, and then calculate maximum efficiency equal to maximum MA upon VR. So try to solve these two examples. दोस्तों, आपको आज की वीडियो अगर समझ में आई होगी तो मैं आशा करता हूँ कि आपको लॉ ऑफ मशीन की कोई भी एग्जांपल सॉल्व करनी आती होगी। आशा करता हूँ कि आपको आज की वीडियो पसंद आई होगी, तो आप ज़रूर शेयर करेंगे, लाइक करेंगे। मैं आपसे इस पैंडेमिक सिचुएशन में गुजारिश करना चाहता हूँ कि घर में ही रहे, सुरक्षित रहे, अपने और अपनों की केयर करें। Thanks for watching this video. Be with us for the next video. Keep watching and motivating us. Thank you.